Hola. ¿Qué pasa? Nada. Okay. Let me show you my fluency in Spanish. We are ready. We are ready. You look ready. I can see right now. I can see you all in the studio audience land. You are ready for this. You are ready for. Are you ready? Are you ready? Are you ready? The quadratic equation. Boom. Oh, what? I've been warning you about that quadratic coming up, and guess what? It starts out right off the bat. Problem number 1 on tonight's lesson. All right. So our content for today, we'd be starting out right into the quadratic. So far, we've done the rule of 100 in every one of our previous problems, and we're doing those ice charts, and that x just cancels out. It's too small. But not in problem number 1, people. Not in problem number 1. Let me show you. We have two acids, HCl, H2SO4. And you know, yes you do, you know that these are both strong acids. So they break down and ionize 100%. We get arrow only to the right. Arrow only to the right. So in the first problem, we have 0.04 molar of each one of the two acids. And the question is, what's the pH of each one? And you might go, oh, it's going to be the same, right? It should be the same. I mean, they're both strong acids, and 0.04 molar for each. Yeah, same pH, yeah. Because this is easy. This one's easy. This is a strong acid, so whatever you have for the molarity becomes your H concentration. So you have 0.04 molar for this. Put it into the pH equation and get a pH for it. You can do that. Go ahead, do that right now. See what you get. Okay. This one, being strong, 0.04 molar, breaks down to 0.04 molar of this. Yeah, but here's the catch. This is a diprotic, 2-hydrogen acid. That means the strong acid is the first hydrogen that comes out. The first hydrogen comes off of that 100% of the time, and you end up with the hydrogen ion in what's called a bisulfate ion. The bisulfate is an acid. But don't all those all come out? No, they don't. That you know, hopefully, because you know your strong acids, is not one of them. That's not that. They're different. So bisulfate is not a strong acid. It's weak. So what happens? What does that mean? That means that once this is formed, some of it will break down and form some hydrogen and some sulfate ion. How much hydrogen? Well, it's weak, so not very much, but some more. So when it comes to the diprotic acid, or the monoprotic, you get 0.04, and go ahead and do a pH on that. This one you get 0.04 plus a little bit more hydrogen. So you get more hydrogen out of this acid than you do that acid, and therefore this is going to have a lower pH because more hydrogen means more acidic, lower pH. Okay, oh, so that's what makes it a quadratic, right? Because it does like this. No, it has nothing to do with it being a quadratic. In the next problem, problem 2, we have a weak diprotic acid, which you don't need a quadratic for, because in the next problem, the X will cancel. In this problem, it doesn't. Well, why not? Let's check it out. Remember the rule of 100? You take the initial concentration, 0.04, and you divide it by the K value of the weak acid. This is a weak acid. Its K value is 1.3 times 10 to the negative 2, which is 0.013. Same thing. You divide those. Yeah, I hope you can see that that's not going to be close to 100. Like 3 or something like that. 0.04 divided by 0.013. 3.08. Not 100, people. What does that mean? That means when we do this problem out, the x on the bottom, the blah blah minus x, the 0.4 minus x is what it's ended up being, is going to, this one, yeah, 0.4 minus x. That is that x on the bottom, it's not going away, which means you have a quadratic equation. Okay, so good news and bad news for you. Ready? The good news is, this problem's a quadratic, and it takes a lot of math to go through it and not make a mistake. That's the good news. How's that good news? Well, what's the bad news? The bad news is, on the next test, okay, coming up, next test coming up very shortly from now. This problem will be on there. Yeah, that sounds like bad news. No, that's not the bad news. The bad news is I'm only going to use it for a bonus problem, so you don't have to do it. Well, how's that bad news? Because it's fun, that's why, and who wouldn't want to do it? Okay? Come on, we need an attitude adjustment, people. So, wait a minute, let me repeat that one more time. Some of you are going, wait, what? Okay, so this problem, number one, the quadratic problem, going through the solution of this whole thing will be not required on the next test. And I forget which problem I'm going to put it in there, but I'll let you know prior to the exam. Okay, remember, blah, blah problem, I don't know, whatever it is, maybe it's problem 10 or something, is a bonus problem, so you don't have to do it. If you choose to do it, you can get some bonus points added to your test score. Okay, so now, seeing how some of you are probably going, all right, well, I'm out of this video, and some of you might have left because you know you don't have to do this problem. So I am not going to go through, and it would take me 20 minutes to go through the quadratic and making sure I'm explaining each step because I don't know what your math ability is and how you remember it and blah, 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 blah. 20 minutes is actually about a 30-minute problem if you and I were actually together in class when we're doing this. So I'm not going to do this video out for a few people who might want to do it. Well, how would if I want to do it? How am I supposed to get my bonus points if you don't do it out? I have done it out. I did it out on paper. So what I'm going to do is I'll put the document into essential documents. It's in essential documents. You can go find it. And it will say quadratic problem solution. All right, find it. You can follow through the quadratic and try it. And if you think, hey, I can do this, then do it. And then take the time to do it. It'll give you some bonus points, up to 5 extra bonus points. So you can tag on 5 points to your test score if you get everything right. Okay, that's a good deal, right? And if you don't want to do it, it won't hurt you. It won't hurt you. All right, so yeah, that's it for problem number 1. If you want to take a look at the quadratic solution, go in essential documents, find it. If you don't, just move on to problem 2, or the next video, okay? Next video, yeah.